when a RAG query is too vague to match the right chunks. HyDE turns the question into a better retrieval target before embedding it. You'll learn the shape of a workflow that drafts a hypothetical answer for a vague question and ranks aligned documents. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Many retrieval problems start with a user who cannot name the right terms. They send a short ticket or a vague question. A direct embedding of that short text often misses the best document. Because the corpus uses domain phrasing the user did not supply. HyDE flips the script. It asks a language model to imagine the kind of answer a helpful agent would write, then uses that imagined answer as the retrieval cue. Practically, this raises recall for queries that lack jargon and reduces the need for heavy query engineering. The idea is simple. Instead of embedding the bare query, we create a richer pseudo-answer that contains the signals a retriever needs. Imagine a user says, "Video buffering problem." A draft reply might say, "Clients experience persistent buffering due to small streaming cache and network jitter." That drafted wording hits the corpus phrases better. Strengths are better recall and simple integration. Weaknesses include possible hallucination, so we add safeguards. We will build a tiny example that shows the full loop. First, we measure a raw embedding baseline. Then, we generate a HyDE draft. Next, we compare rankings. Then, we blend the draft with the original query to limit drift. Finally, we synthesize a short RAG answer, grounded in the top contexts. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now we measure the simple baseline to make the recall gap visible. This snippet builds baseline SentenceTransformers retrieval on a tiny incident corpus. Here we set up model equals SentenceTransformer to encode both documents and queries. Call model.encodeDocument to turn each incident into doc embeddings, and use model.encodeQuery for the live question, so we respect asymmetric encoding. We compare vectors with util.cossim and pick the top hit with scores.argmax. The printed output shows which document led and its similarity score, so you can hear exactly how a short query can miss the best match. The baseline shows a gap, so we need a richer retrieval target. Next, we draft a hypothetical answer with a generator. This example prompts a Transformers pipeline to draft a HyDE hypothetical answer for the query. For vague tickets, the retriever lacks signal, so we ask generator using Google Flam T5 base to sketch the troubleshooting reply you'd hope to see, and we fix randomness with setSeed42 so the demo is repeatable. The prompt injects the live query and asks for a short diagnostic response. The result is HyDE answer, which we then embed with model.encodeQuery to get HyDE scores. We also look at HyDE peak to quantify how much closer the corpus looks when you search with the imagined note. Seeing the HyDE draft move scores is encouraging, but we must verify it actually changes which documents rank highest. This code contrasts baseline and HyDE rankings to show which document now leads. We grab scores top K3 for the raw query and HyDE scores top K3 for the synthetic draft. Map their indices back to the docs and expose baseline best and HyDE best side by side so you can read real titles or snippets. That side-by-side print makes it clear whether HyDE elevated a truly more relevant chunk, like a buffering explanation, or whether the draft just shuffled noise around. A drafted answer can drift into hallucination, so we next blend it with the original query to keep user intent anchored. This snippet blends HyDE and raw query embeddings to moderate hallucination risk. Since synthetic drafts can wander, We mix HyDE with QueryVec, using an alpha weight to keep the user's wording in play. We normalize both vectors with torch_nn.functional.normalize before combining, so cosine scores remain meaningful. Then score the combined vector against doc embeddings with util.cossim. Turning alpha up favors the HyDE signal when the query is very vague. Turning it down reins in drift when the user already provided solid terms. The printed result shows which document wins under the blend and how much the combined similarity changed. With a controlled blend, we can fetch the top contexts and hand them to the generator for a grounded reply. This example stages a tiny HyDE enhanced RAG pass from retrieval through answer synthesis. After blend scores.topk2 selects the top contexts, we concatenate their text into HyDE context so the generator sees real evidence instead of only the hypothetical draft. We build a response prompt that includes the context, the original user query, and a short instruction for the model. Then the same FLAN T5 pipeline that made the HyDE draft produces RAG answer. The printed fields confirm which document indices supported the reply and display the concise, grounded answer you can hand downstream. This toy maps cleanly to a real system. Replace the small corpus with your incident database. Swap FAISS or another ANN for fast nearest neighbor lookup. And run the same HyDE loop as a microservice that returns top contexts plus a short synthesis. You retain the hybrid safety of blending and the practical recall gains of synthetic expansion. Recap: HyDE means generating a hypothetical answer to enrich retrieval. Use it when user queries are short, vague, or lack domain terms. Caveat: synthetic drafts can drift, so always validate ranking changes and consider blending with the original query. Next step: tune the alpha blend weight to balance recall and hallucination, and measure how that trade-off affects downstream answer accuracy. If practical AI engineering helps you, subscribe and watch the AI engineering videos.